बिस्मिल्लाहिर्रहमानिर्रहीम। अस्सलाम वालेकुम। मैं फ़खर लोधी हूँ आपके साथ एक बार फिर से। दिस इज़ आवर 14th लेक्चर ऑफ फॉर्मल मेथड्स फॉर सॉफ्टवेयर इंजीनियरिंग। फॉर्मल मेथड्स में अभी तक हम हॉर्स लॉजिक और उसकी डिफरेंट वेरिएशंस और उससे रिलेटेड जो मुख्तलिफ जो इश्यूज़ एंड हमारे पास जो टूल्स एंड मेथड्स हैं उनको हम स्टडी कर रहे हैं। पिछले लेक्चर्स में वी हैव बीन डिस्कसिंग हाउ टू यूज दिस पर्टिकुलर मेथड टू डेवलप आवर कोड इन कंस्ट्रक्शन. Idea behind that construction is that we develop our code in such a way that there is no need to prove the correctness. It is constructed by using all those principles which we are supposed to use for verification. So जब हम इसको construct इस तरीके से करेंगे, keeping all those things in mind, that means starting from the precondition we develop the code and ultimately we reach the post condition. That means the construction itself is proven to be correct. So this is one area that is getting a lot of attention, and we are continuing to discuss this in this lecture also. In the last lecture, we were discussing how to use these concepts in developing the programs that involve loops. किस तरीके से loops में हमें ये चीज़ help कर सकती है. Once again, remember, loops में आपको analysis चाहिए होता है. It is not automatic. और वो एनालिसिस आपका क्या है? यू हैव टू फाइंड द लूप इनवेरिएंट, यू हैव टू फाइंड द बाउंड फंक्शन, यू हैव टू फाइंड द डन फंक्शन. सो जब इन सारी चीज़ों को आप मिला लेते हैं, देन यू हैव टू आइडेंटिफाई द इनिशियलाइजेशन स्टेटमेंट्स, कैलकुलेट द इनिशियलाइजेशन स्टेटमेंट्स, कैलकुलेट द लूप बॉडी दैट विल मेंटेन द इनवेरिएंट कंडीशन, and then that will maintain the sanctity of your bound function and the done condition. So in that particular for that particular case, हमने पिछली बार एक example देखी थी, summing of array elements, and I hope कि आपने इसकी बाकी चीज़ें जो हैं वो complete कर ली होंगी, including the initialization statements and including the body of the loop. Last time we were discussing a very interesting problem known as the Dutch national flag problem. What is that Dutch national flag problem? Let us once again look at the situation here. What we had was set of balls arranged randomly. There are three colors. We have the white color, we have blue color, and we have the red color. And the problem is, or the question is, how to arrange these balls in the order that we have these colors in the Dutch national flag, so that after arrangement we should get this new situation where we have red color, all the balls having red color followed by white followed by blue. So this is the final arrangement that we want. Remember, we wanted to have an efficient solution, a solution which was supposed to be of linear time complexity, big O of n. So our bound functions and the done, they should be found or identified accordingly. Invariant condition, we had to find out the pre and post conditions. So I hope you have looked at the problem and have tried to solve it yourself. If you have been able to solve it, it's very good. It's very interesting problem. But let us anyway discuss the solution in the class also. In this solution, what we will do is we will try to find the invariant condition. We will actually find the invariant condition. And once we will see, once we have the invariant condition, the rest is going to follow, because the invariant condition is supposed to help us in finding the bound function, finding the body of the loop, identifying the body of the loop, finding the done variable, the variables used to control the loop, and so on and so forth. So this is what we have. So the key to the problem, key to the solution to this problem is finding the invariant condition. How can we find the invariant condition? Let us try to understand and let us try to discuss it. So what we will do is we will define three Boolean valued functions, red, blue, and white, and we will say that red I evaluates to true if the ball at index I is red. Similarly, we will have blue I and white I. So we have three functions, red, blue, and white. The purpose of these functions is basically to check the value at any given index. So the value present at that given index, if we say, is it red? So we say red I. If it is red, it will give us the answer yes. Similarly, we can check whether it is white or whether it is blue by invoking this function. We say, the value present at index I, if we say white I, it will give us true if it is white, otherwise it will give us false. So these are the functions. So basically using these functions to check the values or the colors of the ball present at that particular index in the collection. Now, once we have that, the other thing that we need to do is we need to define a function swap. Swap I and j will swap the balls present at index I and j. So it will simply swap these. So this will be a big O of one function. So having said that, having these three functions defined, that is red, blue, and white, and the fourth function swap defined, now we think about the solution to the problem. Now we also define two variables r and w. These are the two indices such that we have 0 is less than equal to r, is less than equal to w, is less than equal to n, where n is the total number of balls in our collection. So here what we are saying is that we have these two indices, that is r and w, and the range of the indices goes from 0 to n minus 1. Since we need to have red followed by white followed by blue, so what we are saying here is that we have 0 is less than equal to r, is less than equal to w, is less than n. So all the balls, they have to be present in that range. We have not yet talked about the blue balls, but with the help of these two indices, that is r and w, we are going to define the collection, how this collection works, and this is how we do that. So we have this 0 is less than equal to r, is less than equal to w, is less than equal to n, and for every I between 0 to r minus 1, so I 0 is less than equal to I, is less than r, so going from 0 to r minus 1, we have red I, that is all the balls present from 0 to r minus 1, they are red. And for all I from r to w minus 1, they are white. And all i's for w, for I going from w to n minus 1, they are blue. So what we are saying here is, we have this proposition, and this is what our post condition is. That is, we have these two indices r and w. From 0 to r minus 1, all the balls that we have, they are red. From R to W, all the balls that we have, they are white. From R to W minus 1. And from W to N, all the balls are blue. So we have two partitions, actually three partitions, and these partitions are defined by these two indices R and W. R से 0 से लेके R minus 1 तक, they are all red balls. R से W minus 1 तक, all white balls. And W से N minus 1 तक, all blue balls. So when we terminate, when the program terminates, when we are done, we should get this condition. So this is our post condition. So once we have our post condition, then we need to find out the invariant condition. We will have this loop that will, in each iteration will rearrange the balls so that you ultimately get your post condition. But before you get your post condition, you must have some condition that is the intermediate condition. But that condition is related, has to be related with the post condition, so that in every iteration, जब आपकी ये invariant condition जो है, ये gets closer to your post condition. Ultimately, जब आप खत्म होंगे, तो वो post condition में convert हो जाएगी. So we have to find an invariant condition such that, जो उससे पहले true है, loop की execution से, तमाम iterations के दौरान में वो true है, और loop की execution के बाद that condition is true. And when you come out of the loop, that loop invariant becomes your post condition. So this is what we need. Now let us just think about what we have. We have, initially our collection in which the balls are arranged randomly. So let us assume, we have initially, we do not have any arrangement. The balls are, the first ball is, let's say, blue, and the second ball is white, and the third ball is again blue, and then maybe a red ball, and so on and so forth. So somehow we have to have these balls arranged in the proper manner. Let us also, think about this thing. After we have some iterations of the loop, some balls would have been arranged. अगर वो arranged नहीं हो रहे साथ के साथ, तो obviously, we are not getting closer to our solution. So what we do is we say that, each iteration, before and after and during the execution of this iteration, we will have 4 partitions. हमारी final condition ये है कि we end up with 3 partitions. The 3 partitions are red, white, and blue. But as we are working, we started with, no partitions. We started with random. So as we are working, as we are iterating through this loop, some balls are, arranged, balls are swapped, and you pick the ball from here and there, and then you put it in the right bucket, and so on and so forth. So what you should get is, you should get, after each iteration, you should get 4 partitions. 1 partition of red balls, 1 partition of white balls, 1 partition of blue balls, and 1 partition of mixed colors of ball, where we do not really know the arrangement of these balls. Now when we are starting, the partitions that we have, that is the red ball partition, is empty. There is nothing there. Everything is actually in the mixed partition. And as we are solving the problem, as we are arranging the balls, our partitions should become, we should have something in the red, blue, and white, and the partition that has the mixed set of balls should shrink. So with each iteration, your partition that you have that has mixed set of balls should shrink, and other partitions, they should increase. So this is what we want to do, and this is what our objective is. So this is going to be our invariant condition. Okay, so we will define this invariant. So once we are done, at that time the partition with mixed balls will have size 0. So when that partition has size 0, we will get our post condition. That is, we will have 3 partitions with red, white, and blue balls. So, conceptually, if you think about it, it is as simple as that. It is not very complicated. But now what we have to do is, what are the possible partitions or arrangements of different partitions? Remember, finally, what we need to do is, we need to have the red balls, followed by the white balls, followed by the blue balls. So these partitions, they have to be in that order. Now the question is, where is your mixed partition? The mixed partition could be at the start, it could be the first, it could be the second, it could be the third, or it could be the fourth partition. Iska kya matlab hai? Let us look at this slide, and I'll try to explain with the help of this figure what I mean to say. So here are our 4 possible combinations. As I said earlier, we have to have our red, white, and blue partitions in that order, and the mixed partition could be, in this particular case, the first option is the last partition, second option is it is the first partition, going from left to right. Third option is it is the third partition, and the fourth option is it is the second partition. As you can see, these are the first and the second, they are kind of mirrors of each other, except that, we maintain the order of red, white, and blue, but as far as the mixed partition is concerned, it is at the either end of the collection. And we can say the same thing for number 3 and number 4. In this particular case, the mixed partition is in the middle. So it is either the second one or the third one. So once again, it can be thought of as a mirror. So we only have to look at either the first one or the third one, because the solution, if we find the solution to the first one, we will have a similar solution to the second one. And if we find the solution to the third one, we will have the similar solution to the fourth one. As you can see, we have basically 2 choices. The other 2 choices, they are the mirror images of the other 2 choices. And we can very easily show, please think about it and try to do it yourself. We can very easily show that if we choose the second option, that is the mixed partition in the middle, that will give us a better solution. Think about it, why did I make that statement? बहरहाल ये चीज़ जब हम इस एग्जाम्पल को करेंगे, इसका सॉल्यूशन जब हम ढूंढेंगे, so that will be very obvious and clear also. So assuming that we choose either the third one or the fourth one. So once we have that, assuming that we chose the third one, so we will have the red, the white, the mixed, and the blue partition. ये हमारे पास combination था. What can we say when we have this partition? What we need to do is, we need to find out the invariant initial and termination condition. The invariant condition is, what we do is, we add one more index, and this index is index B. So the index B is what we have in this particular case. From W to B minus 1, we have the mixed set of balls. And from B to N minus 1, we have blue balls. For the red and white balls, we will have the same that we had earlier. So the invariant condition in this particular case becomes, we have 0 is less than equal to R, is less than equal to W, is less than equal to B, is less than equal to N. So this B is an extra variable that did not appear in the post condition. And we say for every I from 0 to R minus 1, the color of the balls is red. And for every I from R to W minus 1, we have white balls. And for every I from B to N minus 1, we have blue balls. And our objective is, we will stop when B and W, they are equal. So when B and W, they are equal, that means, we will have nothing in the partition mixed. So अगर आप इसको गौर से देखें तो फौरी तौर पे, although we have not written that in the invariant condition, but that is obvious that the mixed balls are from W to B minus 1. And when we have this B equal to W, that means that partition will be empty. So in this particular case, what we have done is, we have introduced another index, and that index basically defines the partition with mixed balls. जब हमारी post condition थी, post condition में हमारे पास 3 partitions थी. So we could work with 2 indices. We already knew the starting point and we knew the end point. So start and end हमारे पास था, और बीच में हमने 2 लाइनें हमने ड्रॉ करनी थी कि हमारे पास रेड बॉल्स किधर तक हैं और वाइट बॉल किधर तक हैं, और उसके आगे हमारे पास ब्लू बॉल्स हैं. बट when we are working, still working on the solution, the problem is not completely solved yet. That means we need to have 4 partitions. Partition for red balls, partition for white balls, partition for mixed balls, and partition for blue balls. So ये जो हमारी चौथी पार्टीशन आ गई, इसकी वजह से हमें एक नया वेरिएबल इंट्रोड्यूस करने की जरूरत पड़ी, और उस वेरिएबल को हमने b कह दिया. दैट इज द इंडेक्स ऑफ द पार्टीशन which has the starting index of the partition which has blue balls. So the blue balls go from B to N minus 1, where the range of the indices goes from 0 to N minus 1. So आपके जो मुख्तलिफ जो partitions हैं, आपके जो indices जो हैं, 0 से R तक जो आपकी है, we have 0 से R minus 1, those are the red balls. R से W minus 1, those are the white balls. W से B minus 1 is the mixed, and B से N minus 1 is the set of blue balls. So ये आपकी invariant condition बड़ी simple सी बन गई. ये invariant condition अगर आप इसको गौर करें, इसके बारे में सोचें, तो बड़ी आसानी से ये आपको initial condition भी आपको फराहम कर रही है. Initially, what do you have in your collection? The collection is random. That is, जो mixed balls जो हैं, that is what you have. So to start with, when you start, आपके सारे के सारे balls, they are present in the mixed collection. आपकी red balls की collection is empty, white balls की collection is empty, blue balls की collection is empty, mixed ball की collection has the entire set. So what should be the values of these different indices? Your starting point is 0. 0 से R minus 1 तक आपके पास red balls हैं. So what does that mean? If that collection is empty, for example, if you have the value of R to be equal to 1, सो 0 से लेके r-1 दैट विल बी 0, 0 से लेके 0 हम एक बॉल की बात कर रहे हैं, बट वी डू नॉट हैव एनीथिंग in the collection. So the value of r has to be 0. The same is true for your w. Since you do not have anything in w, the range for white balls goes from r to w minus 1. So r is 0 and w minus 1, let's say आप उसको फिर w को 1 कर देते हैं, तो w minus 1 अगर 0 हो जाएगा तो फिर collection is not empty. There is one ball in the collection. So the value of w has to be 0. What about b? आपकी जो mixed set है, it goes from w to b minus 1. Alright? w आपका 0 पे है, that we have already seen, and so we have the entire set present in this mixed collection. That means the value of b has to be, this range goes from 0 to n minus 1, so the value of b has to be n. So that is your initial condition. Your initial condition is r is equal to 0, w is equal to 0, and b is equal to n. So that gives you the entire collection in your mixed partition. The rest of the partitions, they are empty. And note one thing here, this statement here still fulfills the invariant condition. So ये आपकी initial condition हो गई. Now let us think about the bound function or the done condition. ये दोनों बड़े मिलते जुलते हैं, आपस में इनका बड़ा क्लोज रिलेशनशिप है. When are we done? We would be done when there is nothing left in the mixed partition. Mixed partition कहां से कहां तक है? W से लेके b minus 1 तक. So when w is equal to b, that means w से b minus 1 तक, b minus 1 एक उससे पहले आ जाएगा, so the range would be empty. So our termination condition is that we get w is equal to b. So when w is equal to b, we are done. So w इधर मूव करेगा और b शायद पीछे मूव करेगा, and at some point in time they will coincide. So that is our condition for terminating the loop. What is the bound function? Bound function, once again, how many balls do we have in the mixed partition? We have the entire set, and that set is from 0 to n minus 1. So the bound function is b minus w. So that means, the number of iterations that we need, ये हमारे पास total है. So जब w and b they coincide, we will have this partition to be equal to 0. And that bound function will also be equal to 0. So this is what we have. So the initial condition here is r is equal to 0, w is equal to 0, and b is equal to n. The bound function is b minus w, and the termination condition is b is equal to w. With that, we now start to look at the algorithm. Now, what is this algorithm? How should this algorithm work? Let us just think about an intermediary state when some of the balls, they have been arranged. So we have, we have not yet finished. Some balls, they still need to be arranged, and some balls, they have to be arranged. So we need to arrange the balls present in the mixed partition. So what we do is, we look at the ball present at index w. Mixed partition is from w to b minus 1. So we look at the first ball in the partition. Now there are three possibilities. The ball is either red, or white or blue. Now also remember that we have the white partition adjacent to the mixed partition. So the left of mixed partition is white partition, the left of white partition is red partition, and right of mixed partition is blue partition. That was the invariant that we chose. Now we have this statement. Now we look at the ball present at index W. Like I said, there are three possible values: red, white, or blue. Let us look at the simplest case. If it is white, what do we need to do? Now remember that we have the white partition adjacent to the mixed partition, and the indices, they go from R to W minus 1. So if the ball present at index W is white, what do we need to do? All we need to do is expand the white partition by 1. And how can we do that? We can simply add 1 to W. So we will move the index W by 1 position to its right. Now we have a partition of white balls which is 1 bigger than the previous one. So it has 1 more ball, and the partition of the mixed ball has 1 less. So if the ball present at index W was a white ball, all we needed to do was simply add 1 to W, and the invariant condition would still remain the same, because we have from R to W minus 1, all these balls are white. So this is our first condition. So the first condition is written as, if the ball at index W is white, so we have white W. That means all we need to do is we say W is equal to W plus 1. Now look at the second condition. The second possibility is that the ball is red, let's assume. If the ball present at that index is red, what do we need to do? What can we do? One possibility is we shift all the white balls to right, and then we somehow pick that red ball in our hand or put it in some temporary variable, shift all the white balls to right, and put the red ball in the empty slot, and we will have all the red balls in the first partition, and then followed by the white balls. But that requires moving a number of white balls, and if we have to do it again and again, obviously you can see that would involve another loop. So that solution will not be a very efficient solution. It will not be a linear solution. So what else can we do? Note one thing here. We have all the white balls here, all the red balls here, and the ball after the white balls, after that partition of white balls, the ball next to that is a red ball. So what we can do is we can pick the first white ball, and we pick this red ball, and if we swap these positions, what will happen is the ball present at the first position in the partition, that is position R, will now be red, and the ball present at position W will be white. So what we have done is we have increased the partition of the red balls by 1. The number of balls in the white partition, they are the same, but there is another difference. That is, we also have to update the indices. And how do we update the indices? we can simply increment r by 1. So that means all the balls from 0 to r minus 1, they are red balls. We increment the value of w by 1, so all the balls from r to w minus 1, they are white balls. And since we have added 1 to w, that means, once again, the partition that contains the mixed balls the size of that partition has been reduced by 1, so we have one less ball to worry about. So it is getting closer to this B here. So W पहले यहाँ पर था, आपने उसको एक आगे मूव कर दिया, अब आपके पास छोटी partition हो गई. So this is our second case. So the second case is written as, when the ball present at position W is red, we swap R and W, we increment R by 1 and we increment W by 1. Now we have the third case. Third case is, we have a blue ball present at position W. So if the ball is blue at that position, once again, what are the possibilities? Now what we want to do is, we want to put this blue ball in the right partition containing blue balls. So what we do is, we pick this ball from position W and we put it at position B minus 1. Remember, balls from W to B minus 1, they are all mixed balls. Red, blue and white mixed. We don't know the colors. So what we do is, we put this W and put it at B minus 1. All balls from B to N minus 1, they are red, they are blue. So when we have added one ball to this partition, we change the index to -1. Okay, the ball at position W is still, we don't know the color, it is still mixed. But in this particular case, what we have done is, we have shifted B to B minus 1, and once again, the partition that contains the mixed balls, the size of that partition has been reduced by 1. So this is what we get. So when the color of the ball at position W is blue, we swap B minus 1 and W, and we decrement B by 1. So these are the three possible cases. So what we have is, हमने start किया था अपनी post condition से. With the help of the post condition, we identified the loop invariant. और ये loop invariant जो था, that was very, very similar to our post condition. The only difference in that particular case was that, जो post condition थी, उसमें we had 3 partitions. And with the loop invariant, we needed to have 4 partitions. Because एक partition ऐसी थी जिसको हम solve कर रहे हैं, और उसमें जो balls जो पड़ी हुई हैं वो mixed हैं, और उसको आप different partitions में आप इधर से उधर कर रहे हैं. अब इन balls को move करने का, आपने अपनी loop invariant की condition ढूंढ ली, उसमें एक नया index आपने add कर दिया, और that was about it. There was nothing very difficult about it. Once you have the loop invariant, the rest follows. It is straightforward. The loop invariant gives you the bound function and the done condition. Bound function was कि जब आपकी वो partition खत्म हो जाती है, जिसमें आपके पास mixed balls हैं. So आपने कितनी balls को आपने solve करना है, कितनी balls को आपने rearrange करना है, that is given by the number of balls in your mixed partition. और उसकी range क्या है? उसकी range है आपकी B से W से B minus 1 तक. So जब W and B they coincide, that is W से B minus 1, we will have an empty range. We are done. So the bound function was obvious. एक बार आपने इनवेरिएंट आइडेंटिफाई कर लिया, बाउंड फंक्शन बड़ी आसानी से आपको नजर आ जाएगा. अब इशू रह जाता है कि आपकी लूप की बॉडी का. सो हर इटरेशन में आप क्या करें? हर इटरेशन में यू नीडेड टू वर्क टुवर्ड्स द फाइनल ऑब्जेक्टिव कि ये जो आपका लूप इनवेरिएंट है इसमें वो जो पार्टीशन खत्म हो के अल्टीमेटली यू विल गेट योर फाइनल ऑब्जेक्टिव, दैट इज योर पोस्ट कंडीशन, कि आपकी मिक्स की पार्टीशन खत्म हो गई, बाकी आपके पास 3 पार्टीशन रह गई, रेड की, व्हाइट की एंड ब्लू की. सो नाउ द क्वेश्चन रियली इज व्हाट डू यू डू. और उसमें हमने देखा कि देयर वर 3 केसेस. You examine the ball, the first ball in the partition of mixed balls, and you have to put it in the relevant partition. So there were 3 cases. So those 3 cases are your selection statement. वो 3 cases क्या थे? आपके white ball, आपका blue ball या आपका red ball. And either you simply, in the case of white ball, what you did was you simply extended the white partition, and in the case of blue or red ball, you swapped the 2 balls and then once again adjusted the indices, and you will have a new set. And the side effect is यानी कि आपकी वो इनवेरिएंट अपनी जगह पे रहते हैं कि वो पार्टीशन फ्रॉम 0 to W-1 you will 0 to R-1 is your red partition, from R to W-1 is the partition that has white balls, from W to B-1 is the partition that has the mixed balls, and from B to N-1 is the partition that has blue balls. And in each iteration, you were adjusting the indices such that the value of the number of balls in the mixed partition is decreased by 1. So, अब आपके पास हर बार problem size आप छोटा किए जा रहे हैं, and ultimately आपकी B and W they coincide, and at that time you stop. So these were the 3 choices that you had. These are the 3 cases, और उन cases पे आपने appropriate action लेना है. So that is your body of the loop, and that is your if statement or the guarded Dijkstra's guarded command that you can have. So body of the loop आपको मिल गई, आपको initialization आपको बड़ी आसानी से मिल गई. You have the loop invariant, उसने आपको इनिशियलाइजेशन दे दी बड़ी आसानी से. एंड इनिशियलाइजेशन क्या है कि इनिशियली एवरीथिंग इज इन द मिक्स्ड पार्टीशन and the rest of the partitions are empty. So you have to adjust the values of these different indices, that is R, W and B accordingly. और ये आपको इनिशियलाइजेशन मिल गई. सो यहां पर अगर आप इसको देखें तो आपके पास सब कुछ मौजूद है. आपके पास इनिशियलाइजेशन कंडीशन है, आपके पास लूप इनवेरिएंट है, आपके पास बाउंड फंक्शन है, आपके पास बॉडी ऑफ द लूप है, आपके पास पोस्ट कंडीशन है, एंड यू आर डन. एंड दैट्स अबाउट इट. दैट इज योर एल्गोरिथम. और इसको आप कोड में लिख लें, इसको आप कन्वर्ट कर लें, और आपका काम खत्म हो गया. बड़ा ये इंटरेस्टिंग प्रॉब्लम है, और इस प्रॉब्लम को मैं जिस तरीके से मैंने पहले कहा था कि ये एक बहुत मशहूर प्रॉब्लम के साथ बड़ा क्लोजली रिलेटेड है. कुछ आपको समझ आया, कुछ याद आया कि वो कौन सा प्रॉब्लम है? अगर आप इस पर गौर करें तो यकीनन आप उस तक पहुंच जाएंगे. लेट मी गिव यू अ हिंट. लेट अस जस्ट अस्यूम कि हमारे पास 2 कलर्स के बॉल हैं. कोई भी 2 कलर्स हो सकते हैं, वाइट एंड ग्रीन, लेट्स अस्यूम. और हमने उसको इस ऑर्डर में अरेंज करना है कि पहले वाइट और उसके बाद ग्रीन. तो हम इससे मिलता जुलता इसी तरह का हम एल्गोरिथम एक डेवलप करेंगे जिसमें हमने 2 पार्टीशंस के साथ काम करना है, और जब इंटरमीडिएट स्टेट में हमारे पास 3 पार्टीशंस होंगी. सो ये जो 3 पार्टीशंस आपकी हैं, these 3 partitions, they are white, mixed and the green. और अल्टीमेटली आपकी जो मिक्स्ड है वो श्रिंक होती जाएगी, और जब वो 0 हो जाएगी उसमें, then you are done. तो ये जब आपका जो केस है, ये कौन सा केस है, कुछ आपको याद आया? बहुत मशहूर ये प्रॉब्लम है। जी हाँ, ये प्रॉब्लम आपके पार्टीशन का प्रॉब्लम है आपकी क्विक सॉर्ट के एल्गोरिथम में। क्विक सॉर्ट के एल्गोरिथम में व्हाट डू यू डू इज यू पिक अ पिवट and you say कि after you have arranged all those things, all the values that are smaller than the pivot, they are on the left. All the values that are greater, they are on the right, and then the pivot is going to be at its right place. Now just imagine that, instead of just putting the pivot at the right place, we are just thinking about this thing that we have all the values that are smaller than a given number on the left and all the values that are greater or equal to a given number, they are on the right. ये आपका बिल्कुल वही पार्टीशनिंग का प्रॉब्लम बन गया। और अगर आप उस पार्टीशनिंग के प्रॉब्लम को देखें, उसमें भी एग्जैक्टली इसी तरीके से काम हो रहा है। इनवेरिएंट कंडीशन है, आप ये दो इंडेसीज हैं, इनको आप मूव किए जाते हैं और इस पार्टीशन को बढ़ाए जाते हैं, इधर 0 से लेके i-1 तक या i जो भी आपका इंडेक्स चल रहा है। ये पार्टीशन वो है जिसमें सारी वैल्यूज पिवट से कम है। इधर जो आपका j वाला इंडेक्स टिपिकली आप यूज करते हैं n-1 से j तक जो हैं वो दे आर ऑल ग्रेटर देन द पिवट, और बीच वाली जो वैल्यूज हैं दे आर मिक्स्ड, यू रियली डोंट नो, एंड यू आर डन when the two indices they overlap. So basically आपकी बीच वाली पार्टीशन आपकी खत्म हो गई। So ये पार्टीशनिंग का ये वही एल्गोरिथम है। यहाँ पर in this particular case we are working with 3 partitions. In that case we work with only 2 partitions. तो देखा आपने, how interesting is it? So बहुत से प्रॉब्लम्स आप देखेंगे कि ये इसी तरीके से एक दूसरे पे मैप हो जाते हैं और बड़ी आसानी से आप उनके लिए ये प्री एंड पोस्ट कंडीशंस और इनवेरिएंट आप निकाल के यू कैन फाइंड द सॉल्यूशन फॉर दोस प्रॉब्लम्स। ये जो हमारा प्रॉब्लम्स था, ऑब्वियसली दिस डिस्कशन इज अ वेरी लॉन्ग डिस्कशन। इसमें हम बहुत सारे एल्गोरिथम्स पे बात कर सकते हैं, बहुत सारी चीज़ों को हम देख सकते हैं और उस पर हम अपनी गुफ्तगू जारी रख सकते हैं। But unfortunately, obviously, we have limited time. So, मैं यहाँ पर अपनी discussion on this topic I will close. जो हमने construction का काम था और होर लॉजिक का बेसिक जो मुख्तलिफ जो हमने टेक्निक्स थी, जो वेरिफिकेशन में, स्पेसिफिकेशन में, वेरिफिकेशन में और कंस्ट्रक्शन में, वो हमने पढ़ी हैं, हमने देखी हैं, और आपने देखा कि कैसे ये होर लॉजिक जो है ये आपको अच्छे मैकेनिज्म्स और टूल्स मुहैया करता है जिसके ज़रिए आप अच्छे रोबस्ट और वेरीफाइबल आप प्रोग्राम्स आप बना सकते हैं और आप अपने प्रोग्राम्स की क्वालिटी बेहतर कर सकते हैं। बिकॉज वंस इफ़ यू कैन प्रूव दैट योर प्रोग्राम वाज करेक्ट, देन देयर इज नथिंग लेफ्ट। ऑल्दो दैट इज अनदर एकेडमिक डिस्कशन वेदर यू स्टिल नीड टू टेस्ट द सिस्टम और नॉट। उसकी टेस्टिंग जो आपको एक्सेप्टेंस टेस्टिंग के लिए उस चीज़ की ज़रूरत बहरहाल होगी कि यूज़र की एक्सपेक्टेशंस क्या थी, लेकिन विद द गिवन स्पेसिफिकेशंस, जो भी आपने स्पेसिफिकेशन आपको मिली हैं, उन स्पेसिफिकेशंस के साथ आप प्रूव करते हैं कि आपका प्रोग्राम इज़ करेक्ट। अब जो इसके बाद जिस टॉपिक पे मैं अपनी गुफ्तगू करूँगा वो है एप्लीकेशन इस सारी थ्योरी की ऑन एक्चुअल बिल्डिंग प्रोग्राम्स। सो देयर हैव बीन मेनी एफर्ट्स। इस पूरे थ्योरेटिकल नॉलेज को लोगों ने अप्लाई किया है, उसको यूज़ किया है, एंड दे हैव डेवलप्ड अ नंबर ऑफ टूल्स एंड टेक्निक्स एंड एक्चुअली प्रोग्रामिंग लैंग्वेजेस एंड मॉडलिंग टेक्निक्स ऑल्सो। सो अगले चंद लेक्चर्स में हम उन मॉडलिंग टेक्निक्स और उन टूल्स को देखेंगे। जो पहली चीज़ इस सिलसिले में हम देखेंगे वो एक चीज़ है जिसको हम कहते हैं डिज़ाइन बाय कॉन्ट्रैक्ट। डिज़ाइन बाय कॉन्ट्रैक्ट आज से तकरीबन 15 साल पहले मायर ने इंट्रोड्यूस करवाई थी बेस्ड अपॉन these very principles of pre and post conditions and invariant conditions, हम इसको देखेंगे. और उस डिज़ाइन बाय कॉन्ट्रैक्ट को यूज़ करते हुए बहुत सारे टूल्स बने हैं, जिसमें आई कॉन्ट्रैक्टर एंड जे कॉन्ट्रैक्टर टूल्स हैं. आईफल प्रोग्रामिंग लैंग्वेज में ये सपोर्ट बिल्ट इन है, और ये टूल्स जो हैं ये आपको सॉर्ट ऑफ जिसको हम कहते हैं कॉन्ट्रैक्ट्स लिखने में आपको मदद देते हैं, और फिर एट रन टाइम यू कैन वेरीफाई वेदर दीज कॉन्ट्रैक्ट्स आर फुलफिल्ड और नॉट. इस पे हम बात करेंगे आइंदा. इसके अलावा जो दूसरी इसकी एप्लीकेशन है, जो डिज़ाइन बाय कॉन्ट्रैक्ट की ही एक तरीके से एप्लीकेशन है, जिसको हम ऑब्जेक्ट कंस्ट्रेंट लैंग्वेज कहते हैं. ये ऑब्जेक्ट कंस्ट्रेंट लैंग्वेज या OCL, ये नाउ इट इज पार्ट ऑफ द UML स्टैंडर्ड. सो दिस इज अ लैंग्वेज, और दिस इज अ नोटेशन, और दिस इज अ टेक्निक through which you can define constraints on your objects in UML. और बिल्कुल इसी तरीके से जिस तरीके से आप उसकी प्री एंड पोस्ट कंडीशन और डिफरेंट इनवेरिएंट कंडीशंस आप स्पेसिफाई करेंगे. एक्चुअली वहाँ पर जो इनवेरिएंट कंडीशन का कॉन्सेप्ट है वो हमारी इनवेरिएंट कंडीशन से थोड़ा सा फ़र्क है, क्योंकि हमने इनवेरिएंट्स जो हैं वो लूप्स के कॉन्टेक्स्ट में ही स्टडी किए हैं. वहाँ पर इसका कॉन्टेक्स्ट थोड़ा सा ब्रॉडर हो जाएगा, लेकिन बहरहाल वो मिलती जुलती चीज़ ही होगी, आप देखेंगे. सो ऑब्जेक्ट ओरिएंटेड प्रोग्रामिंग में अब नाउ इट इज कमिंग एज वन ऑफ द मेन स्ट्रीम एक्टिविटीज. सो दिस एप्लीकेशन ऑफ होर लॉजिक एंड फॉरवर्ड मेथड्स, हम इसको अगले लेक्चर्स में हम स्टडी करेंगे. अगले लेक्चर्स तक आप मुझे इजाज़त दीजिए. उस वक्त तक खुदा हाफिज़ और अस्सलाम वालेकुम.